Anybody know who this is?
Yeah, Charles.
Charles who?
Lindbergh.
Charles Lindbergh.
Pre-baby.
So, okay, so you guys all know, okay, you're right. He's famously, or his kid was kidnapped and caused all kinds of scandals and stuff. So, in 1919, how he actually got famous was way back in 1919. Actually, we just passed last week was the 100th anniversary of what? You guys know?
First war.
The U.S. entry, not the start of World War I, but the U.S. entry into World War I. World War I really, I think we typically think of World War II when we talk about things like environmental impact, overfishing, all this and that as sort of defining a new era of population growth, a new era of technological expansion, winches on boats, and more efficient engines and things like that. And that's totally valid. But really, World War I was an incredibly important marker for technological innovation. Things, unfortunately, like the insanity that's been going on in Syria right now, chemical weapons, that's when we first introduced chemical weapons in a large-scale manner to kill even more people than we otherwise would, because our species seems to love to do that. But all kinds of other stuff. And in particular, World War I was the first introduction of aerial. We had some balloons and stuff in the Civil War, but really what we consider modern aviation really started in World War I. It got much more mature in World War II. But anyway, this is 1919. So this is we'd had biplanes and some things like that in World War I, but not super sophisticated. And so this was a prize that was put forward, $25,000. And the prize was to simply be the first one to do a continuous solo flight over the Atlantic Ocean. And that was it. You know, whoever does it first gets the money. Could be an African, could be an Asian, could be a North American, could be a rich guy, whoever, young guy, old guy, lady, dude, whatever. It was just $25,000 for the first person to do it. And so after there were several teams that were competing, but Charles Lindbergh won that, right, in the spirit of St. Louis. So he went from the U.S. and he landed in France. So that's where his fame first came, and then he became this, and that prize, that game, if you will, that contest, really helped spur a huge interest in aviation. And make no mistake, the development of remotely piloted systems, this is a cultural phenomenon, right? This class is not a robotics class. It's not a sociology class. It's really about practically using this new technology, right? And that's what this prize did. It got it captured the public's interest. Before this, most of the planes were more typically biplanes. This was still what we would call a relatively slow airplane, but biplanes even slower, right? The control systems very rudimentary, very a stick that I push right left, and then very easy to be broken, and the like. But it really captured the public's attention. It would be wonderful if we could talk about, hey, air flight can save energy. Air flight can connect cultures and people. Bullshit, right? That's not how our species operates, unfortunately. Not trying to be a pessimist, but just speaking from the record. Is the American going to do it? Or is the Brit going to do it? Or is the Frenchie going to do it, right? No way, America's going to do it, right? So that notion of sort of the football contest, the baseball contest, us versus them, while it causes numerous problems that we can all envision, it certainly gets people up and interested in a technology, right? And so that's what this prize did. And right now, the modern version of this, we have the X Prize. So we have 5 teams right now vying to land humans on the moon and come back. Those are gonna launch end of this year or next year. and who knows? There's 5 teams. Let's see if anyone does it. But the idea there is we're in the midst of an ocean X Prize right now. We were going to participate, but we're too stretched thin, so we didn't participate. Which is making some deep sea drones. There's an X Prize, another Ocean X Prize right now that you guys can all participate in this summer, where people are making apps to make environmental data more accessible to the public and to you guys. And so there's a whole suite of apps that have been created that you guys can download for free in a month or two and use and decide which ones you like, and then you can vote as to what you think are the most helpful. In that case, some of this is technology driven. Others are more about how does the fisherman find a market for the fish that is landed, right? And how can they do more direct to consumer marketing, that kind of stuff. So these prizes can be really valuable. So obviously, if you're the Lindbergh, if you're the person participating, you could win. You could either win the prize, from the get-go, or it can be more like a NASCAR kind of thing, right? Where you might get a little bit of money if you placed third or fifth or whatever. But the point is that competition serves not just to have fun and not to just have the participants doing it, but it also helps popularize some technology or some ideas. That's our idea. In a nutshell, that's the idea with this drone data race. This is the first one we're doing. We'll probably totally screw it up. I will probably totally screw it up, right? And that's fine. But we're going to learn a lot from this first trial balloon so that next year, as this becomes an annual thing, we'll actually know how to do stuff, right? Having never done one, there's all these questions and there's all these open-ended variables. We have no idea. So again, even if nobody shows up 2 weeks from now, you guys can fly the Phantom around or the whatever, and we can go through it, and we can get a sense for how this thing works, right? To set up one of these races is a non-trivial thing, so we can't just do it on a random Tuesday and just see, right? So we need to kind of actually go through the motions. So let's talk about this notion of drone racing, right? That's started as a small thing and has gotten increasingly popular. Hold on. This is an example of a small course on a university campus, and this is the idea. So rather than the type of units that we typically use for our research, these use much smaller units, generally speaking smaller flight time, but are designed to go fast. So what you're looking at is the feed from a forward-pointing camera that it goes to, you can do it however you want, but typically it goes to goggles is how most of the racers have it set up. You don't have to have it that way, but the idea is that you can look, and when folks practice for hours on end, they get really good at this. Whereas you guys are looking at the craft, we're looking for birds and everything. These guys are just focused on going forward, and they go very fast. So they go 60, 70 miles an hour, and so pretty much whatever they're going to bump into is straight in front of them. So there's less worry about stuff behind them. Also, these are small. These are units about this big, dinner plate size or so. So they're not like our big honkin' Inspire or things like that. And the idea is these guys just like a regular race, just like a cross-country race or a NASCAR race or a horse race, whatever. There's a defined track, and you need to go around. Typically, there's some number of loops, might be 3, might be 4 circuits you have to complete. And just like skiing or other things, and sometimes there's gates. There's defined areas you have to go through. You can't cut the corner. And typically, folks will lay out things like these dots, so it's easy to tell where to go. And in this case, there are various hazards. This is on a university campus up in Canada. And so these guys have a forest, and so they decided to make use of their existing things. So that's an example of the kind of thing like we're gonna do. Okay, so this is the other extreme. So this is the big monetized version. This was a race down in Dubai this last year. This is the World Championships. So just like other industries and other entertainment sports, there's qualifying rounds, and you have to do regionals, and then the best folks in the regionals, etc. So in this case, this is done at night, and this is the FPV camera at the front of the craft, and this guy's done it at night. Why is it done at night? So it looks cooler. There's no reason why, other than, well, it can be crazy hot in the desert. But basically, this is to make it look awesome. So instead of just, you don't need all this fancy LED stuff, but it looks cool on TV, right? So this is designed to be broadcast. And so, right, so this course involves having to go really high, go low, go through, go around, all that kind of stuff. And then, of course, what happens all the time is these guys crash. So on this highlight reel, you probably won't see a crash, but you'll see some of these guys cruise around. So the very first international or world contest we had 2 years ago was won by a 15-year-old from Great Britain. So you need not be a 60-year-old guy with $1 million necessarily, right? If you have the skills, right? So one of these, now just like a race car, these guys trick out their units with all kinds of extra, bells and whistles. But the standard racing drone package is, I don't know, like $500 or something on that ballpark. And just like a NASCAR or motocross, whatever, you could spend a gazillion $1 million doing all kinds of fancy things. But you don't necessarily need to, right? It's mostly about the skill of the pilot. And so that's an example. We will not be doing this, just to reiterate. We will not be doing this. But it's interesting now that this is becoming a thing. Now,
do they tend to run these races with just one drone on the course per time? Or
yes.
Do they ever do it motocross style where everybody just
They do both. They do both. So let's look at an example of. Okay, so where drone racing really got going in places like LA, et cetera. So this is so the question was, do we ever have racing simultaneously? And the answer is yes. So this became pretty big in the States last couple years, primarily because of the FAA. So the FAA, because of all the regulations we had at the time, we were not allowed to fly out, or there were restrictions about flying outside, and you had to have special permits and everything. And so what would happen, I know mostly the story from LA, what would happen is these guys would go to a place like this. Let's have a look at this, right? This is in this case, this is from Australia, but it's the same idea, which is an old warehouse. We have a lot of old warehouses in urban centers like Los Angeles. They used to be used in the case of Los Angeles for things like the garment industry and all these other things that either because of mechanization or because of overseas stuff or because of changed supply chains where people the companies don't necessarily want to store a gazillion million blue jeans, let's say, right? They want to make them on demand and put them right into the stores immediately. So the need for bulk storage, in at least these urban cores, has gone down. Interestingly, the need for bulk storage has gone up in places like the Inland Empire and the Central Valley, where we have storehouses for things like Amazon and Google. But and drones and robots are an increasing part of that story, but we'll leave that to the side. The point is we have these abandoned areas, relatively depopulated compared to the number of folks in the past that used to reside and or utilize these spaces. And as you can see here, a lot of them are, if not fully open to the public, different folks have gotten in there and, broken beer bottles and all the stuff you would envision. And so because of the issue with airspace with the FAA, people were going in and going to the owner of this space and say, hey, can we rent your warehouse for 2 weeks, right? And the person owning the warehouse is making no money on it now, right? They're just either losing money or they're holding it for some future investment to do something. And so they said, hey, what are you going to do? And the guy says, nothing. We'll put up we might put a little bit of paint here and there. We might put up some temporary things, but everything we're going to put up is going to come down. And we're going to fly little teeny robots that weigh a couple pounds. And they say, okay, you got to have liability insurance in case someone trips and hurts themselves. And the owners and the race folks go, okay, cool. Anything else? And they say, we just need emergency contact and this and that. And it's like all good. So this drone racing really got going in these indoor spaces, right? So in addition, it avoids the FAA stuff, but it's also a bit safer in the sense that they're not going to bump into birds. They're not going to go over a roadway. They're not going to cause any threat to people not engaged in the racing efforts, right? So it's kind of a bit of a win-win thing, right? So things started growing here. Now, the issues with can anybody think of some issues with flying the, now again, this is different from our typical research applications, but let's just watch this because you guys won't pay attention to what I say. So we'll just watch these guys go. Again, this is the first person view.
There's no wind in there.
That's right. Excellent. Yes. So definitely no wind. And in this case, all the contestants are in the center, akin to where the mechanics would be, let's say in a NASCAR race or something, or a road race. And so these guys are basically just going over the same old spots, right? So they're doing circuits, and there's a certain number of laps that they have to do. And in this case, this is a pretty simple one. This is essentially an oval, or basically an oval course, and so it's not that complex. The trash on the ground doesn't matter, right? The wind doesn't matter because we're shielded from the wind. And for these small units, that's non-trivial, right? For our bigger, heavier units, there you go, right? And so this happens all the time.
Well, that's how they stop them, I think, they fly into the net.
Yes, yeah, well, yeah. So that happens all the time, but they also crash all the time. And so just like, I don't want to be morbid, but I would say there's a certain proportion of people that enjoy watching races for perhaps some of the dramatic effect. Maybe not the hardcore race enthusiasts, but some people, right? And so when you watch the shows on television, whatever, whenever there's a crash, when they cross the line, you hear polite clapping. But when there's a crash, the whole crowd's like, oh! Like everybody's into the crash, right? Oh, damn, did you see that, right? And then in this case, because it's not a requirement, but in most cases, definitely the broadcast television stuff, they're archiving all this video, right? And they replay it. Let's watch the idiot run into the column, right? Ah, what a dummy, right? You know, that kind of thing. You know, classic reality television. So that really got stuff going, and that really helped get this thing going. And so what these guys would do is they would charge, you know, different amounts of money to participate, and maybe either nothing or maybe a few bucks to come and be an audience member. And it was a thing, right? So it's just like other pop-up things we've had that have increasingly coming along with our connected culture. You can pop up, there's a store here, pop up, there's a protest here, pop up, there's a drone race this weekend, and whatever the address is, right? And so this really has led to several, or I shouldn't say led to, but helped drive several innovations, like higher recharge battery technology, higher torque engine motors for rotors, and various things like that. Really driven things, small goggles, right? That virtual reality goggles, the display goggles that are really easy and convenient. And then the other thing about this whole deal, right, is that no GPS in here, right? We're inside. So just speaking with some guys from Sea-Track, these guys that are making these new batteries for some of the kind of ocean-going robots that we're working on, and they want to test their device, and they're talking about going up to MBARI, Monterey Bay Aquarium Research Institute, and I was saying, well, you guys should go to the MAST Center, because these guys are in Monrovia and they're in Southern California. You guys should go to MAST and do it, and they're like, yeah, the problem with both those places is that they're covered. They're trying to test some stuff, in this case in a giant pool, to see how their technology works in the water. But part of that key thing is about data transmission, satellite transmission, and when you're indoors, that doesn't work, right? So there are clear problems with being indoors. From our perspective, what it means is nobody can have GPS assist. I mean, in theory you could if you did a bunch of fancy stuff, but generally you don't, right? So it's all you. It's all your right stick, left stick, whatever. And if you overcorrect, it's your fault, right? So mostly what we utilize is we use these stabilization routines, these assisted technologies to make our unit more stable, because that's what we want in a research context, right? We want the camera to stay level. We don't want to spook the bird, what have you, right? So one of the things Chase and Tim are working on today, or possibly today, is trying to get the stabilization control for the S1000 to be a little bit more stable, right? Problem they were having last week was that the computer was overcorrecting basically, and so it wasn't being as stable as we like. But the point is with this is there's no stabilization. It's 100% you. And for research, that's probably not a good thing unless we're trying to chase a invasive species or something, unless we had some noxious predator we're trying to get out. But generally that's not good. So it's a different skill set, right? So the folks that operate these things are really, really good pilots because they have to be. If they're not, they're going to crash every 30 seconds and they're not going to win. It's going to be an expensive sport for them, right? So lack of wind, good for these smaller, so you can have smaller units and not worry about a gust of wind throwing you off the course, either damaging your unit or just making you, not win that round or not be competitive. And it also really has helped spark this subculture now. So now, if you guys were to Google, well, let's do it. So we have U.S. Drone Racing Association, International Drone Racing Association, Drone Sport Association. There's another international drone. And let's see. What if we pick something like this? So here's some example of organizations. So there's the international one. There's the X-Class Racing. And we have all these different associations, Australia, international, what have you. And so all these things have grown up because the technology is at the price point where it's affordable to folks, right? And now there's enough interest that, maybe 5 years ago there would have been you and your buddy, and maybe you're going to do this, and then maybe some people are going to go complain to the park officials or whatever, and then you're going to be kind of screwed, right? But now there's this professionalization, if I can use that term, or standardization of some of the activities, and so now more and more people can get into it, right, and try it. And so again, spurring technology. Now there's things that you can buy. If you're a super build-it-yourself hobbyist, you can acquire one of these units and assemble it from total scratch. Right, just like the unit we have right here, we could 3D print basically all of the body if we wanted to. Although most of these guys have metal chassis, but you could do that. Or if that's not your deal, if you just want to play, you could order for on the order of $500 or more. You could order an already built one, right? Like a stock, basically a stock unit, and you could just go use that, right? They come with all its parts, and so whereas again 5 years ago that was hard. You pretty much had to build it yourself and had to be really into the maker movement or have access to folks who could help you when something goes wrong. And so all of this is helping to push the use of this technology forward, right? Just like auto racing helps spur innovations in the retail auto market, right? So anti-lock brakes, those various kind of things, which all started as a weird tricked out thing to help the racer folks go whatever that many more miles faster or take the curve that many more miles safer, or in the case of harness and restraints, make them more able to survive an accident or a crash. Same thing, those things eventually bleed in, and in fact you'll see not a lot, but you'll see some automakers actually actively advertising that the stuff that our racing teams invented, we now mom with the minivan and the kids can have the racing technology, right? It's a little bit like what, but clearly that has some value. Okay, so the last little bit by way of prep before we start talking about our particular one. Let's.
Don't they have leagues now? They actually...
Okay, so now you'll have all these guys pushing all these things. So here's the one downside. In my opinion, here's the one downside with this technology. Yeah, blackout, blah blah blah. I have no idea what I just clicked. I'm doing a free advertisement for these guys. Okay, so right. This is what the industry, or this is what the drone racing is really getting more and more and more about this kind of stuff, right? How in this case you guys are flying over an estuary, a salt flat wetland. So they're flying around, and the idea is, look how fast we can go, all right?
Here comes a cormorant.
Right. So speed is not necessarily a bad thing. That being able to go faster, more thrust, more whatever, that's a benefit. Being able to transmit this high quality data feed, that's a good thing, right? That we can see applications of that beyond racing, etc. But the problem, in my opinion, and it's not a problem, but one of the limitations, let me say it that way, with this racing effort is it's all about the pilot. It's all about the pilot, and it's all about this. How fast can we go? It's all about the performance of the technology. We are interested in much more than that. We're interested in the application of this technology. So our race is not a drone race, quote unquote. It's a drone data race. So what we're trying to do is so our race is going to have two components. The first component is just to, like everything else, go do the course, right? Go, whoever goes through the stuff the fastest, we're good to go. But too many folks have come to talk to us about starting a drone business, or I meet them at a meeting and they're starting a drone business, and they have their FAA permissions, and they have their physical unit, their platform, and they say, I'm ready, I'm gonna go. And that sucks. That's not right. Because the other important leg that is almost or very, very frequently missing from this sort of wild west rush to use this technology is what is the data product? What is the information you're going to collect with this device? One, and two, how are you going to give it to the end user of this data in a useful form? So drone racing is great. It gets people interested in it. It gets people, sucked in, and they're playing around. But it's only about going fast. So our race has two components. One is go around the course and complete the cycle. But also it's about collecting information. So our race is on Earth Day, and it's about an oil spill. So the idea is, so there'll be winners of who gets through the course fastest, right? And if that's all you do, great, boom. But then on Sunday, to answer your guys' questions, on Sunday we're gonna have the GIS lab open, and we've gotten permission to have Pix4D installed on our computers, which we haven't talked about Pix4D yet in this class. But essentially, it's the photo stitching software that we use to create the maps. And the idea is you're going to make an elegant, and so the idea is at the end, and this is what you guys are going to help us decide, but at either the end of the course or midway in the course, there's going to be a quote unquote oil spill. And you have to image the oil spill.
Whoever gets the best image.
Right. So you can win in speed in terms of just doing the course and getting back fastest. That's cool. That's the thing on Saturday. On Sunday, there's no race per se, but that's a day for participants to create an elegant data product. So this can take whatever form. It's open-ended, so people want to be creative. You can do whatever form you want, but the basic idea would be like a little poster, right? You don't have to physically print the poster, but make a poster. And the idea is, hey, tell me about this oil spill. How big is it? How many barrels? That kind of stuff. So the idea is create some tool, and not something necessarily it's open-ended. So maybe someone just wants to make a table, and that could be okay, but I'm hoping, depending on who participates, that people get a little more creative, and maybe we make a three-dimensional model of the spill or calculate the volume that way, etc. So that we can also talk about that today. But the idea is there's the speed component and there's the data component. So you can win the speed, you could win the data, and then there'll be an overall winner of the two. And originally, we had thoughts of using infrared and all this other stuff, and we realized most people won't have that. So all you need is a decent camera on your unit that you could image, and you could use that to build your images. So that's what our drone data race is about. Again, it's our first pass at this. We'll probably totally muff it up, but it'll really help us, I think, in future years do this. This is going to be open to anybody that wants to participate. So high school kids, retired folks, professional people, hobby, whoever wants to do it can do it. Cool? All right. So with that, let's take a pause.